Hi, this is Mr. Ward, and this is a video key for Geometry Do Now 31.2. So let's start with this. So I'm going to propose, I'm going to find x here, which is over here, and we want to propose some way we might find the area of this cluster of right triangles. Well, to start off with, let's start analyzing the triangle sides we've got. We've got a 15 and a 17. The 17 is a hypotenuse. So this one smells a lot like the 8, 15, 17 right triangle. So I'm going to say this is 8 because this is a Pythagorean triple. And then I've got 6 and 8, and that smells like it's part of the 3, 4, 5 triangle family. So if that is 3 times 2, that's 4 times 2, so this would be 5 times 2, or 10. Okay. Now, 26 smells a little like 13 to me, and that would be 2 times 13, that's 2 times 5. And there is a 5, 12, 13 triangle, which tells me that this one is 2 times 5, 2 times 12, 2 times 13. So this would be 2 times 12 over here, which will be 24. And then, of course, there is the 7, 24, 25 triangle. So that has to be 7. Now, what's really nice about this set of triangles is that we have bases and heights. Every time you have a right angle, that means that you can treat one of the legs as the height and the other leg as the base, and you just use the base times height over 2 equation, and we could work out all of the areas of these triangles. So this one here would be 60 because 8 times 15 divided by 2 would be 4 times 15. So that would be an area of 60. So I'll just make a note here. That's 60 right there. 6 times 8 divided by 2 is 3 times 8, so that's 24. And then over here we've got 10 times 24, which should be divided by 2, so we can call that 10 times 12. So that's 120. And then over here we've got 7 times 24 divided by 2, so we can call it 7 times 12. So that one is 84. And we would have all the pieces of the area of this right triangle. Of this set of right triangles, I should say, this cluster of right triangles. Okay, so x equals 7, and we can find the areas of all because we have the bases and heights of all. Now let's take a look at the next one. All right, so find x and y. Well, this and this are parallel because this is a right angle to the same line, and that makes these two parallel lines, which tells me that we have drawn a line parallel to the base. And if we've drawn a line parallel to the base, that means that this is to this as this is to this. Well, 3 times 4 gets me 12, so 5 times 4 will get me y. So y, pretty easy to get. Y is going to be 5 times 4, so that's going to be 20. All right. Now, if that's 20, then that's 25 from, so this whole thing is 25 here. And this whole thing is 15. So then we've got what's looking to me like a 3, 4, 5 triangle. This is definitely not drawn to scale. The x aspect of this is squished for sure, because this side here, if this is a 3, 4, 5 triangle, then this side is the 3 side, 3 times 5. This side is the 5 side, 5 times 5. So this is going to be the 4 side, or 4 times 5. So this one that is drawn to be shorter than this is going to actually be 20. So x is 20. So x equals 20. Y also equals 20. They're both 20. So x and y are both 20. And I think that's all of them for this one. So I helped.